Okay, so what on earth is this thing? As we can see, it's got a battery in the middle connected to these two copper rods, connected to some aluminum foil. Essentially what this thing is, you stand on it and it sends electricity through your legs into your body. And the rods, you hold them with both your hands. And if you hold the negative with your left hand, it's relaxing, so it's negative or yin. And if you hold the positive in your left hand and the negative in the right, it's stimulating. So this one's relaxing and the other is stimulating. Ooh. Which is fascinating. Now I'm going to show you how this is built. All we need is a power source, and you could add a variable resistor to the circuit if you wanted, or a switch or something. And then we have two rods. Now if you don't have rods, you can just use cable. You can just strip cable and wrap it around your wrist or your hand or whatever and use that. This kind of reminds me of, oh no, my soldering has failed. Oh well, it reminds me of those Japanese trees. They got like the rope tied around them in the shrines or whatever. Anyway, so it's essentially just a piece of electrical cable which has been wrapped and tied around this copper rod, which I also sanded the copper rod with a very fine grain sandpaper, so it's very smooth, but you can see it's been a bit, it's been abrased or whatever, been sanded. And then I soldered the cable kind of shut, and I soldered it onto the pipe, which didn't really work, as we can see, but it kind of has made it a little more stable. Then you just put a piece of tape around like so, and around here, and then we go above there, we go around again, pushing tape into, and then we go below like that. So there's a nice little handle, because this is all it is. It's just an electrically conductive handle. As I said, if you don't have copper pipe, you can use plate. You can use things like steel or aluminum or anything electrically conductive, but again, steel, like iron and steel, gathers magnetic energy, so it'll produce different effects. Copper is very nice because it's very, like copper warms up. Anyway, then what I've done to connect it to the battery, and you can use a DC generator. I'm fascinated in actually how would AC power work. As you can see there, I've made a little loop and I soldered it, and then just connected it to the battery's positive, its pointy end, and you just just tape it over the top, tape it under the bottom. It's not the so you can see this one fell out. It's not the best way to do it, but it does kind of works. And there we go. Now, as we can see, this is an incomplete circuit. If I touch it, it is a complete circuit, and it will eventually begin to heat up. At least the battery should begin to heat up, because it's short-circuiting. You don't want to short-circuit it. There we go, it's starting to heat. Yeah, we don't really want to do that. It's a short circuit. Technically, I think when we're holding it, it's kind of a short circuit. I'm not sure. Anyway, if I hold these, the effect that I get is very nice. It's essentially like, it's just, when you sit and you meditate and you produce energy naturally. I think it's like through time. You just passively through time. Or just say you eat a bunch of food, or you drink like a sweet drink. It's got a lot of sugar in it. Like sugar gives you that energy. Things like energy herbs like ginseng or reishi, they give you that energy, and you can feel it like flowing to the parts of your body which are sore. Like yesterday I did some exercise, right? So I got a bit of muscle soreness, and I can feel it just flowing to those areas, which is really nice. So it's really nice to hold this. Like, it's so relaxing, and as I said, this way is stimulating. You feel it more in your head. So if you want more like mental energy, more creative energy, then you know, positive in the right, in the, excuse me, the left hand. And if you want more relaxing, more physical healing energy, then it is negative in the left hand, positive in the right. Here's my voltmeter. We're on 20 volts DC, 1.48 volts, basically 1.5 volts. That is lower. Now, of course, I did short circuit it, so, oh, there we go. It's gone lower again. That's lower than it was. It was about, take it away, put it there, take it away, put it there. It was about 1.6, and then it went to 1.5. And amperage, it was originally at about 2.7, 2.6-ish, you know, conservatively. And we're sitting at about 2.3, 3, nearly and a half. So the current, what we call the amperage, which is essentially how much juice can it give, the same way that if you have a power source with a low amperage, it can't make a motor spin strongly. You can make a motor spin, but once you add resistance to that motor, it will be weak, right? It won't spin very much. Like, you grab it and it's just like, it's not really spinning. If it's high amperage, it'll still spin, even if you add resistance to the motor. So it shows that the power, basically the power it can give, that's the way I think about it, has gone down. Meaning, assumingly I didn't just lose it through short circuiting it, we're actually using energy of the battery. We're absorbing the energy from the battery. Isn't that cool? Okay, going back to this one, as we can see here, we have our power source, negative, positive, on some food foil, aluminum foil. Of course, if we have our voltmeter on amperage, we get a reading. Okay, it's gone up again. Interesting. And then we go on voltage again. There we go. So this is electrically conductive. Between here, of course, it's not connected, so technically it's a closed circuit, right? Just to show you that it works. Here we are. Now this one with the feet, because what I found with the hands, it works more the upper body. Like, I feel it traveling through my arms to my lats, kind of my mid back. This one I can vaguely feel coming up my legs. Now, if you use too much voltage, which I'll show you in a minute, the car battery, your muscles, I found the nerves will twitch and the muscles will contract. It's like that. So you don't want to use a lot of, I imagine, a lot of voltage and potentially amperage. I think amperage is okay if you have a lot of it, but the voltage is, that's 1.5 volts. It feels completely fine. I can really feel it in my legs come up. Yeah, so the legs seem to be more resistant than the arms. The arms, because, again, it's the positive part of the body. The legs are the negative, so they can handle a lot more juice. Because what my legs are probably doing with this battery is they're just absorbing, they're acting like a battery. They're absorbing the energy, right? My arms are a little more active, energetically active, right? So you can probably take a lot more voltage to the legs. I probably wouldn't go beyond, honestly, 6 volts. But you're going to have to test it out. Of course, if you practice with this, you're going to learn to take in more. So here is my 24 volt. How much amperage can it deliver? I don't know, man. Probably like 20 plus amps. Like, let's just say it's enough to create sparks. I tried it with this, the 24 volt one. It's just lead acid, lead gel battery for like 3 seconds, and it zapped me. I felt my nerve in my, down the bottom of my arm, like the pinky kind of circuit nerve. It just like twitch, and I was like, oh, and I had to let go. Yeah. So I basically electrocuted myself. So the whole reason I wanted to try this experiment is because I was standing out in the sun, and I was thinking, you know, this feels really nice. This is really good, the energy we're getting off it, but couldn't it be quicker? Couldn't we like capture this or control this or something? Of course, you could use a solar panel and connect it directly to electrodes to touch them, or plates or whatever for your feet. Or you could just connect it to a battery, which then you connect to a system to do that. You know, that's one way. Another idea, of course, is, you know, vegetables and such, and fruits. You know, plants absorb this sunlight, and then you can get it through, you know, sugar and starch and protein and whatever. So here's a kind of weird and interesting experiment. I saw this once before on a Kurenai video. Essentially, on this Kurenai video, a guy was holding a piece of zinc, I think, and copper, and connecting it to like a clock, and he was actually powering the clock just by holding two pieces of metal. And of course, as we should probably know, batteries are essentially just opposing pieces of metal with some kind of like piece of cloth separating them, and an electrolyte, you know, soaking the cloth or whatever. That's a simple battery, right? It's just the kind of opposites in the metal's power. Another interesting thing is that he could get one person to touch one metal, another person touching the other metal, connecting them to the, you know, the clock, we'll say, and then they could hold hands, and the current would flow through them both and power the clock. And if they released hands, it would stop powering it. So here I'm going to touch these, and if we put it on the 2 volts, we can see we're getting 0.6, 0.7-ish, a small amount. Actually, just before we do that, if I stand on this, is it going to change anything? Let's see. Okay, so I'm holding it, and not really. I don't know. Maybe if I have enough voltage. Actually, yes, that is doing something. Okay, and I'm going to stand off it now. And no, pretty much this. Actually, so I've never really gotten that much millivoltage off myself. Meaning, I'm wondering if I got charged from that. Yeah, that's a lot. Usually it's like 0.6. Okay, I'll stand back on it. And it did increase, but it is kind of going, you know, it's still, I'm not getting like a strong enough result. What if I change my foot position? Nope. And I'll get off. Okay. Oh, wait, okay, that dropped. No. I don't know. The only thing I can really say on that experiment is that I definitely don't usually have that much millivoltage, so maybe it charged me. Anyway, so I touch these, and that's what we get, right? And then I touch these, and we get nothing. What happens if I hold these in my hand, and then see what I'm doing? So I'm holding them like that. You see the connected. Look at that. We're getting, it's nearly a battery. It's 1.3. What on earth? Isn't that cool? Isn't that cool? Maybe if we put enough stuff in series, we could get a higher rating. Let's try it out. 1 second. I wonder if I could power an LED off that. That'd be very cool. So we have 2 pieces of copper and 2 pieces, and hopefully this is a little, it's not, might have to scratch it up a bit. I don't know. I'm going to hold it like that. Oops, excuse me. I'm going to hold it like so. And I'm going to hold the other one like so, and also just connect it to, I guess I'll connect it to this. I don't know. And then the positive to this, and then, 1 second. Okay, it's difficult to touch all of these. I mean, it seems to be doing something, but it doesn't seem to.
Looking back on it, the issue here is that I didn't have the metals that I was holding separated by, again, some kind of cloth and an ionic, like salty solution. If I, for example, made up 2 batteries and then held them, I think that could work actually.
I don't know. I don't know. Whatever. Okay, let's just go back to these 2. So, again, negative, positive. And there we go. We're back to that. So basically we are between these, we're producing electricity because of the like sweat. That's one way to say it. Whatever. It doesn't really matter unless you want to go into the physics, unless you're interested in that, why it works. But it does work, and assumingly touching these together is producing like 1.1, 1.3 volts. I can kind of feel it, and I can kind of feel it actually. And I've seen some people selling products.
Again, here I was actually mistaken. I think it's not exactly putting them together, but it's, for example, if you held a rod of zinc or magnesium and a rod of copper in, the left and the right hands, you could do that experiment and feel, and then you would get a charge from holding those rods.
Imagine you make one of these, right? And then you cap the bottom and you fill it with a zinc rod. Or actually, how would you do that? I don't know. Maybe you like wrap this in this stuff, right? And then when you grab it, it's producing a current, right? Because we probably don't need, we can probably just have like one hand. We don't need 2 hands, do we? Here, so I'm touching them both, and yep, it's not as high. We've halved it, but it does. And then we go back to 2 hands, and it, same thing. Whatever. Oh, actually, I'll use this. Okay, so yep, touching these 2, and then I'm touching with 1 hand, and there you go. So okay, so it does work. Now the thing is, the difference between this and the battery is that if we go to milliamperage, we are producing pretty much nothing, I would imagine. Yes, pretty much nothing. Yeah, actually, I don't even think we're, I don't know, it's like so low, it's screwed up. Whatever. Point being is that we are getting a voltage, the same way we made all those batteries. We are getting a voltage, but we're getting pretty much no amperage, which is the reason why this connected to the battery is a lot stronger. The amperage is like the power. Alright, here's the last experiment I want to try. So here I've got the DC generator, and of course I'm very fascinated to test the differences between DC and AC with this kind of power. But for now, what we can do is test this out, and yeah, I've got 2 some of these connected, and so we go positive to the, positive, hook him up like so. And we can see between these 2. Oh, we're just not getting enough. There we go. Yep. So it's kind of short-circuiting it, and then we hook up the negative, and there we go. So it's all hooked up, and we're getting. You can see if I touch them together. I gotta be careful. Now let me put this on like a volt, because I'm wondering, are we getting any current flow between this? Because it's DC generator, it's not a battery. So I'm going to touch them and I'm going to feel. It does feel like it's working. Okay, it does definitely, yes, it feels like it is working. Okay, now I'm going to enhance it, I'm going to double it. So we're going to go to 3. I hold them and it feels stronger. Yeah, it does feel stronger, that's for sure. And I'll swap over just, yeah, okay, I can feel that. And we'll go to about 5. I'm trying to see like what's my upper limit, because eventually I'm gonna try to get my hands on eventually it probably will zap me, and that's not so good. It's not like a really bad zap, but it's like a little, it's like a muscle jolting zap. So let's enhance it to 8 or 7.5ish, 7ish maybe, and it feels fine. I can really feel my back, my upper back is just like, oh, it's good. I feel all the energy's going there. That's where I did a lot of exercise. So let's go to 10. Okay, around that, around 10. Still feels fine. Even though we have 0 current, I can still feel it, like undoubtedly. And if you try this yourself, you know, if you have a DC generator, maybe you'll feel it, yeah, as well. All right, we'll put it up to like 13ish, and still not getting any weird nerve thing like pains or anything. Yeah, it's like all the bad areas of my body, like the energetically bad areas, are just being fed with energy is the best way I can say it. It's just like sped up. It's just speeding up the healing process, specifically for my upper body. Specifically for the upper body. Let's try it with the oil for the feet. Right? Okay. And just we're definitely we're getting a bit of current now. So gotta be careful. Yeah, I can definitely feel it. We'll turn it up a bit. So we're gonna go to maybe like 17 volts. See if I can feel more. I don't know. It's difficult to feel. Oh, oh yeah, that's a bit much. Okay, 17 is too much. I could feel it right like the bottom there, and it's just, whoa, that's kind of my, yes, that's, whoa, that's, it's not bad, like, it's a pleasant pain. It's terrible to say, but it's not that bad. I imagine if this was like 30, 50, 60 volts, it'd hurt. I think that's how maybe electromuscular stimulation works, is that they use like 50 volts, 100 volts, maybe 200, even 1,000, and they're just like, it's just pulsed highish voltage, and that's what causes you tense. Let's take that down a bit. I honestly, I was kind of wondering whether that worked or not. Now I'm not. Yeah, now it's odd. I can kind of feel it building up. I definitely don't need any. Yeah. Oh, that's too much. A little too much still. Oh, okay. 15 is too much. Let's go to 13, because we do need to figure this out. Oh, that's too much. I think it definitely depends on your body. But let's drop it down to 10, because maybe I've built up too much energy in my body. And it's like, yeah, I'm getting, it's just in those little toes around there. Oh. I hope you enjoy watching me get electrocuted. It's a terrible thing to say, but I hope there's some kind of intellectual or entertainment value. Okay, that's really, that's something else. I'm gonna drop this right down back to like 2, just to make sure that, because it could just be that I've built up so much energy in my body. That's kind of what I feel, is that no matter what I use, I mean, if it's slow, if it's a low voltage and it's slow, maybe I can slowly handle and process and like circulate it. This is, you know what this is similar to? It's similar to acupuncture. It's got that nerve feeling of acupuncture, that like the electricity running through the nerves. Maybe that's what acupuncture is that you have the metal needle that punctures through your skin. And it's basically just the etheric or the air energy. The needle's absorbing. Okay, this is fine. 2 volts is completely fine. This is absorbing the electric energy in the air. Let's go to 6, because I want to find like a medicinal value that doesn't zap the crap out of you. And you know, like you can use. I want to tell you, what should you be able to use that's not going to zap you, but isn't too low? Because we want this, we want to, really bring this stuff up. We want people to feel it, and we want it to work quickly and effectively. 6 seems to feel okay. So we found 12 was too much. 2 was too little. 6 is fine. 6 feels fine. Let's go to 9. 9 might be too much, but let's find out. Okay, 9 volts. So yeah, maybe the acupuncture it's basically just like stimulating the nerves with energy from the air, because again the air is full of energy. Okay, 9 is feeling okay. I don't seem to be getting electrocuted in my small toes like I was. Alright, look, I'll leave it at that. So 12 is too much, 9 feels fine, 6 feels fine, 2 feels fine. That's for me personally. Maybe 10 or 11 volts could work, but now you know what you can do. And as I said, that 1.5 volt battery that I've got here, see, I'm starting to feel a little bit, but I'm handling it. I'm starting to feel it build up, but it is handling it. It is being alright. This is a 1.5 volt battery, and that I noticed. That was good. That was fine. So even if all you have is a 1.5 volt battery, or if you know how to put these in series, so you can get a 3 volt, or you get a 9 volt, one of those, block batteries with 2 little terminals hanging out, and then you just glue or solder on some, some rods and some copper wire or whatever. You can do that, and this is pretty nice, to be honest. This is good. So what I was thinking, product-wise, what you could build for yourself, or if you've got like a grandparent or someone who's got like a weak back or something, you could build like a board. You make like a wooden frame, right? And you have 2 metal plates which are separated, they're insulated, and then those 2 metal plates, you connect them to a power source. And you could put like a DC generator. You can get you can get a little DC generator off AliExpress. They might have like 15-volt generators, right? Or like 10-volt ones or something. Something small for cheap. Maybe it's like $10, $20, right?